Alright, so here we go on this review before we start diving into LCMs, GCFs, and fraction operations. So here's a couple of words. You're going to have words here and then in the middle of the lesson that you need to make sure to write down. First we have the word divisible. So divisible can be separated into divis and able. Divis is like divide, so meaning divide, and able is like the word able. So this is a number that is dividable, okay? But we say divisible. And it's a number's ability to be divided. Again, a reminder, even numbers are numbers that can be split into two groups without a remainder. Keywords here, split into two. And then odd number is a number that cannot be split into two groups without that remainder. All right, so let's move on. And the first thing I would like to do is I would actually like to look at our divisibility rules. So I'm going to jump those right up to the front instead of putting them at the end like I had anticipated. All right, we'll try this real quick. Sorry, it's going to take me a second. There we go. All right, so here are all our divisibility rules. Okay, I'd like you to take a second and pause and write them all down. And then there's a couple of them that are confusing. Like I feel like 5 and 10 are pretty straightforward. 2 is straightforward. We'll talk about 3 and 9 and 4 a little bit, and you're going to practice them as well. All right, so here again, if it's even, it can be divided by 2. So you're going to write down these numbers into the boxes of yes or no, and then we'll check them when you come to class. So again, if it's even, like 910, it would go in the yes box. If it's odd, like 6025, it would go in the no box. All right, 5 and 10. So to be divisible by 5, it has to end in a 5 or a 0. And to be divisible by 10, it has to end in a 0. So for example, if you take 950, it ends in a 0, so it is divisible by 5, and it is divisible by 10. All right, so you're going to also complete these problems and determine yes or no, are they divisible by 5? Yes or no, are they divisible by 10? And we'll check those in class. All right, the 4s. The 4s are a little bit more difficult. So if you look at the last 2 digits here in each of these numbers, if you notice, they're all multiples of 4. So the multiples of 4 being 4, 16, 4, 8, 12, 16, 20, 24, so on and so forth. Each of these are multiples of 4, which means that that number is divisible by 4. So here I'll do these with you. So here the number ends in a 12. Since the number ends in a 12, yes, it is divisible by 4 because 12 is a multiple of 4. 18 is not a multiple of 4, so it is not divisible by 4. 28 is divisible by 4, so it is a multiple of 4, so this whole number is divisible by 4. Okay. The divisibility rule for 3 can trip students up a bit, but once you figure it out, it really comes in handy for 3s and 9s. So if you add the digits together, so if you break 18 up into 1 plus 8, you get 9. 9 is a multiple of 3, so 18 is divisible by 3. 30 we break into 3 plus 0, which is 3. 3 is a multiple of 3, so 30 is divisible by 3. 4 and 2, even though you wouldn't think it is, when you put them together, they add 6, and 6 is a multiple of 3, so 42 is divisible by 3. Same things with 9s. So up until you get to 99, every single number that you add gets you to 9 in this case. So this would be 3 plus 6 gets you to 9. But then once you get to 99, you got 9 plus 9. So obviously that can't give you 9, but it gives you 18. So as your numbers get larger, this multiple of 9 is going to get larger, could get larger, okay? But each of these is a multiple of 9, so each of these is divisible by 9. Alright, so in this one what you're going to do is you are going to determine, are these numbers that are given here, are they divisible by 3 or by 9, possibly by both, or by neither. So you're going to write these numbers down and you're going to do the practice and decide which box they would fall into. So again, I'll do an example. 345, 3 plus 4 plus 5, so this is 7 plus 5 is 12. 12 is a multiple of 3, so it fits in the 3, but it is not a multiple of 9, so it has to go into the 3 box. Okay, if it can go into 3 and into 9, then it is divisible by both. Sixes. Sixes can get a little complicated. So if you use your rules and you look at 456, 456 is even, so yes, it's divisible by 2. Okay? Then you have 4 plus 5 plus 6. Alright, so 4 plus 5 is 9, plus 6 gives us 15. So therefore, 456 is divisible by 3. So it is also, oops, sorry, that should be a y. It is also divisible by 6. Okay, but then now if you look at the next number, you have 567, which is not divisible by 2. If you add 5 and 6, that gives you 11, plus 7 gives you 18, which means yes, it is divisible by 3, but since both of these are not yeses, then it is not divisible by 6. Both of these have to be yeses in order for the 6 to be a yes. So I'm going to let you go ahead and try 576 on your own. All right, back to some more vocabulary. We have the word factor. So we know factors are numbers that when multiplied together give you a specific product. We can also define them as whole numbers that divide a non-zero number without getting a remainder. The key term in this point is that it's a whole number that divides that non-zero number. So for example, the factors of 6 would be 1, 2, 3, and 6. A composite number is a whole number greater than 1 with more than 2 factors. Okay, so I have 6 would be a composite number because of the fact that it has 1, 2, 3, 4 factors, so it is composite. A prime number is a whole number with exactly 2 factors, 1 and itself. So for example, 2. The only factors of 2 are 1 and 2, so 2 has to be prime. Speaking of factors, when we're looking at a number and we're factoring it, okay, I'm going to give you some step-by-step help here. So I wanted you to find the factors of 12, so this is on there for you in your notes. So step 1, always start with 1. 1 is the factor of every single number. Every number is divisible by 1. All right? So you start with 1, then you think, all right, well, the number itself has to be a factor, and that's going to be the largest factor. So that's going to be your end. So we're making that rainbow here. So 1 times 12 gives you 12. Now I'm going to think about every number in between. Okay, every whole number in between. So the first one I think of is 2. Is 12 divisible by 2? Yes, it is, because it's even. See, those divisibility rules are helping us out. So then I think 2 times what gives me 12? And that's going to go next to the 12, because I would go low and then high. In this case, 6. 2 times 6 gives me 12. Well, since 6 is a factor of 12, that tells me that 3 would have to be a factor of 12. Okay, because 3 is the next number, and if it's divisible by 6, that means it has to be divisible by 2 and 3. So therefore, 3 has to be a factor. So then I think 3 times what gives me 12? Well, 3 times 4 gives me 12, so I know 4 is a factor of 12. And then I make sure to put it inside parentheses. Okay, now you're going to take a look at these numbers, you're going to write them down, and you're going to determine if each of them are prime or composite. Don't get confused though, because just because a number is odd doesn't always mean it's prime. So 29 is prime, because when I go through my divisibility rules, I find that none of them work. But 27, even though it's odd, is composite, because if you do 2 plus 7, you get 9. the multiple of 9. Therefore, 27 has to be a multiple of 9. Alright, now we're going to talk about adding like fractions. So think about building a snowman. As you build a snowman, each time you're adding 1 out of 3 pieces, so 1/3. So here I start and I have 1/3. If I add another third, that doesn't mean that I have 2/6. Okay, I don't have 2 pieces out of 6. I have 1 piece out of 3, another piece out of 3, so therefore this would be 2 pieces out of the 3. So 1/3 plus 1/3 gives me 2/3. I do not add those denominators because I'm not adding to the number of pieces I need to make a whole group. I'm adding the pieces that I have. So here I have 2 pieces out of the 3. Now if I add one more, I have 3 pieces out of the 3. So if I add all 3 of these together, I would have 3/3, not 3/9. So again, when we add or subtract like fractions, we only add or subtract the numerators. I cannot stress that enough. All right? And like fractions means they have to have the same denominator. So 8 and 8 are the same, so they're like fractions. So I keep my denominator, and I add 3 plus 2, which is 5. All right, so then now if I go to the next one, now I'm subtracting. So even though I'm subtracting, if my denominators are the same, it's the same idea. So 10 and 10. So I keep the 10, and I do 9 minus 4 is 5. So my answer is 5/10. Yes, you can simplify it. Okay, if I want to simplify it, I take the 5 and the 10. They're both divisible by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. So in simplest form, that answer is 1/2, which is the same thing as saying 5/10. It's like saying 2 nickels is the same thing as 1 dime. They're both worth 10 cents. They're just different ways of representing it. All right. So here you have a couple of questions. I'd like you to substitute. Wherever you see x, you're going to put in 2/9, and then you're going to solve. So in this case, I have 5/9 minus 2/9, and then you need to tell me what you get. All right. So wherever I see x, I replace it or substitute 2/9, and then you're going to solve. All right. We'll go over these questions that I gave you in class to review. All right, if you have any questions, make sure to write them down and email me so we can go over them in class.